What do living things need to survive? You may be imagining blue skies, green forests, clear oceans, and oxygen-rich air, conditions that keep us comfortable. But Earth as we know it today is just a snapshot in our planet's long history. Past conditions have been very different. Toxic orange skies, an atmosphere with no oxygen, intense radiation, thick sheets of ice stretching from the poles to the tropics. Yet life has survived on Earth through more than 3.5 billion years of radical changes. In its most basic form, life is little more than a set of chemical reactions. To sustain life as we know it, all you need are 3 ingredients: a liquid medium, raw materials in the form of atoms, and an energy source. A liquid medium provides an environment where chemical reactions can take place. For life on Earth, it is water. Water dissolves and transports chemicals and nutrients, and oftentimes it participates in chemical reactions. To have liquid water, a planet must be in the just right temperature range. Too hot, and the water turns to gas. Too cold, and it remains solid. In extreme cold, chemical reactions can't take place. Earth is in the right temperature range because of its distance from the Sun and its atmosphere. Atmospheric pressure keeps our water from boiling away and drifting into space. Carbon dioxide in the atmosphere traps heat like a blanket. Our atmosphere also protects us by reflecting harmful radiation. In their search for life on other planets, astrobiologists look for signs of a liquid medium, past or present. Even a very cold planet may have been warmer in the past, and life might exist in small pockets of liquid water in underground caves or under ice, perhaps warmed by volcanic activity. Astrobiologists also speculate that life may be able to survive in liquids other than water, such as methane or ammonia. Some have even proposed that life could survive without any liquid. Atoms are the building blocks of everything in the universe, including life. Life on Earth depends mainly on the organic elements: oxygen, carbon, hydrogen, and nitrogen, with a little phosphorus and sulfur thrown in. Together, these elements make up more than 97% of the human body. They also take part in life-sustaining chemical reactions. Elements come from stars, so the organic elements important for life as we know it are present throughout the universe. What's important for living things is having these elemental building blocks in a usable form and in continuous supply. For example, life on Earth is based around carbon. Carbon is a versatile element that can be put together to form many different kinds of stable molecules. But carbon trapped in rock is not useful. Cycling brings carbon from rocks into the air and water, where living things can use it, and from the air and water back into rocks. Other elements cycle too. When astrobiologists look for life elsewhere in the universe, they look for evidence of chemical reactions that were likely to have been carried out by living things. But they also ask whether life in other places may be based around elements other than carbon, hydrogen, nitrogen, and oxygen. Energy is also important for directly fueling life's chemical reactions. Living things on Earth get energy either from the sun or from breaking down molecules. Plants use energy from the sun to build larger molecules from smaller ones. All other living things on Earth, including humans, break molecules to make molecules. That is, they break down their food into smaller molecules, releasing energy that they use to build new molecules and to fuel their activity. In their search for extraterrestrial life, astrobiologists generally look for places that have a system of free-flowing energy. On Earth, for example, energy from the sun, gravity, and the planet's liquid core is converted to other forms as it flows through the system. Energy from the sun heats the planet. Together, gravity and the sun generate wind, water currents, and tides, which circulate raw materials. They also cause electrical energy releases in the form of lightning. which can drive chemical reactions and produce heat. The energy associated with our planet's core is described by the theory of plate tectonics. Currents of molten rock slowly move huge land masses, or plates, around Earth's surface. As the plates move, energy is released through earthquakes. Activity at plate edges contributes to chemical cycling. The solid planet crust is pushed into the hot core, where chemical reactions take place. Material from the core moves to the surface through volcanoes and vents, releasing gases and ash into the atmosphere and onto the surface. Together, these circulating energy sources set up the conditions that allow life to survive. Other planets with a similar energy flow may be home to their own forms of life. Astrobiologists ask whether faraway life forms could find a way to harvest energy from sources other than the sun or chemicals, such as electrical or mechanical energy. Understanding the ingredients for life on Earth is a good place to start in the search for life elsewhere. Since we know life thrives on Earth, we can look for similar conditions and signatures on other planets. We can also use what we know about Earth's various life forms and the chemical properties of elements as a springboard to imagine alternative possibilities. Life on other planets may look very different from life as we know it.